Hello class, in this video I will be showing you how to find reference angles. And in a later video I will be showing you how to use reference angles to find the trig value of any angle in standard position. Let's begin. Let theta denote an angle that lies in a quadrant in standard position. The acute angle formed by the terminal side of theta and the x-axis is called the reference angle. And before we begin finding reference angles, I want to bring your attention to the phrase acute angle. The acute angle, if you remember, is an angle that's less than 90 degrees, but it's also got to be greater than or equal to 0 degrees. And that's going to be very important for a few of these examples. Okay, so starting with 150 degrees. I want to find the reference angle for 150 degrees. And I'm going to start by drawing that angle. Going counterclockwise, there is 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So the 150 degree angle is going to be in quadrant 2. So the reference angle is the angle that's formed by the terminal side of theta and the x-axis. So what I'm going to do is I'm going to draw a vertical line from the terminal side to the x-axis. This angle right there is going to be your reference angle. And I'm going to label that theta prime. And how do we find that angle? Well, we know that theta prime plus 150 has to equal 180. So in this case, the reference angle is going to be 30 degrees. Okay, example 8. Again, I'm going to draw the angle. And I'm going to label my axes going clockwise this time. So that's 0, negative 90, negative 180, negative 270. So it looks like this angle, negative 65 degrees, is going to be in quadrant 4. So just like the previous example, I'm going to place a line from the terminal side to the x-axis. And this is the acute angle that I'm going to reference. And that acute angle happens to be the same exact angle as the problem that's given. However, instead of the reference angle being a negative 65, the reference angle is going to be a positive 65 degrees. And that's because the acute angle has to be between 0 and 90 degrees. Okay, example number 9. Okay, we're going to draw the angle. So this is 0, pi halves, pi, 3 pi halves, and 2 pi. 9 pi fourths is greater than 2 pi. So what we're going to do is we're going to take our angle and we're going to go counterclockwise, 1 full revolution, and we're going to stop somewhere in the first quadrant. And this is the angle 9 pi fourths. The reference angle is going to be this angle right here. That is the reference angle. And how do we find that reference angle? Well, it looks like if we take 2 pi and add the reference angle, we should get 9 pi fourths. And that's so because here I'm drawing in red 2 pi. And then if I add the reference angle, that should equal 9 pi fourths. So theta is equal to 9 pi fourths minus 8 pi fourths, which is pi fourths. So the angle we're going to reference is pi fourths. And for the last example, again, we're going to draw the angle and we're going to label our axes going clockwise. And it looks like negative 3 pi fourths is going to be in quadrant 3. So I'm going to draw a line from the terminal side to the x-axis. So the reference angle is going to be right there. And how do we find that reference angle? Well, I'm actually going to give myself a little bit more room here. I'm going to shrink this up. Well, I know that negative pi has to equal the reference angle plus the negative 3 pi fourths. So negative 3 pi fourths plus the reference angle has to equal negative pi. So if I add 3 pi fourths to both sides, you get negative pi fourths. However, theta has to be between 0 and 90 degrees. So we're not going to take the negative pi fourths. We're actually going to use its absolute value. So that would be positive pi fourths. So the reference angle for negative 3 pi fourths will be positive pi fourths, not the negative pi fourths, because we want an angle that is between 0 and 90 degrees, and negative pi fourths is not between 0 and 90 degrees. Okay, now